Okay, so now we're at question 23. The first 22 questions were on a previous upload. We're going to add some numbers together using appropriate precision. Well, number one, we must have matching units, so they all either need to be meters or centimeters, okay? Doesn't matter which way we go. Let's just turn them into, I guess, meters, why not? So centimeters, I'm going to have to move those decimals 2 places to the left. So 2.14 meters to turn that into meters. And then this one also, that's already meters. This one also 2 places to the left to turn that into meters. 0.829 meters. What kind of precision do I have here? Well, I've got 2 decimal points there, so I've got to the hundredths position. This one's to the hundredths position. This one's to the 10,000,000. 10,000,000, the 10,000ths position. Well, I can only add to the least precise number I have there. Okay, so I need to add these 4 numbers together. 28.31. Okay, let's do that. 28.31. These 4 numbers together. Plus 2.14 plus 0.829 plus 3.4891. Okay, so the calculator spits out 34.7681. Okay, however, because I don't have this level of precision with all of my numbers, I cannot report adding them together that way. Okay, unit would be meters here. Okay, it's not correct to do that. Okay, this 28, I only know to the hundredths position. I don't know what numbers might have been over here that I rounded into 28.31. Okay, same with the others. So I cannot carry this level of precision in my answer. The most I can carry is to the hundredths position, so I'm going to round it right here, so it's going to be 34.77 meters. Okay? When we divide these types of measurements, now we need to have our answer with the same number of significant digits as the least significant number I'm dividing. Well, how many significant digits do I have here? 1, 2, 3, 4. I've got 5 there, but I only have 3 in my denominator. Okay, so 834.04 divided by 27.3, I'm going to get some big old number here, 30.55091575, and then my calculator runs out of room. All this down here is garbage, okay? I can't count it as part of my answer. I can only show the same level of significance as my least significant number in my original problem, and in this case I've got 3 significant digits there, so I can only carry 3 over here. So it's going to be 30.6. Okay, no units, right? The meters have canceled out. 30.6. All right. Distance between 2 points and midpoint. If I want to find the distance between 2 things, I simply subtract those 2 things. That tells me what's in between them. So I need to take 7.5, and I need to subtract 3 3/8. Okay, now we did this both leaving them as mixed numbers as well as turning them into impropers, and that's usually the way I favor, quite frankly. So I'll call that 15/2 minus 27/8. We're subtracting fractions, so we must have a common denominator. In this case, it's going to be an 8. So I'm going to have 60/8 minus 27/8. So what's that going to be? 33/8. Okay, 33/8. Now we could turn that into a mixed number at this point, which would be a good thing, or reduce it if we can reduce it. But in this case, we'll turn it into a mixed number. Remember how to do that? You do the old longhand division. We say, well, 8 times 4 is 32, so it'll go in there 4 times. I'll have a remainder of 1, so it'll be 4 1/8. Okay, that is the distance in between those 2. Okay, I take the farther one and subtract the nearer one from it, and I'll get the distance in between. Okay? So what about midpoint? Well, for midpoint, we add the two numbers together and then we divide by 2. So I already did some legwork here with my common denominator. So in this case, I've got some of that already done. 60 over 8 plus 27 over 8. So let me add them together first, and you'll see I'm going to get 87 over 8. Okay, but now I'm going to divide by 2. So write that however you'd like. Divide by 2. It'll be 87 over 16 then. Okay, and I don't think I can do any reducing there, but I could turn it into a mixed number anyway. So what's that going to be? 87. Oh, I don't know. Let me just look a little bit. I'll have 5 that goes in there for sure, right? That'll give me 80. And I'll have a remainder of 7, so it'll be 5 and 7/16. That's my midpoint. Okay, there we go for that one. All right, what's next? Some questions on opposites and absolute values. I just kind of lumped a bunch of things here all together in one problem. What's the opposite of a number? It's the same absolute value with an opposite sign. So what's the opposite of positive 16? Well, the opposite would be negative 16. What's the opposite of negative 81? Well, it would be positive 81. Okay? What's the absolute value of a number? That's just saying the distance away from 50. How many units away from 50 is the number 50? Well, it's 50 units away. How many units away from 0 is the number negative 62? Well, it's 62 units away. Okay? The absolute value wipes out a negative inside it, but it will not wipe out a negative outside it. So if I asked you what is the negative absolute value of negative 85, this outer negative stays right where it is, and then the inner negative gets wiped away, so it's negative 85. Okay, so be able to kind of explain some of that stuff. Okay, adding, subtracting, multiplying, dividing numbers that have negatives. It's order of operation stuff here basically. Subtraction can be thought of as adding the opposite. So if we do the conversions, I'll call that plus positive 30. And I'll call that plus negative 2. Now it's all addition. Yes, I have some positives and some negatives, but it's all addition. Remember we worked examples where we shuffled it around and we put the positive numbers side by side and we put the negative numbers side by side. I prefer just to work through it left to right here. So I'm going to have a negative 4 and a positive 30. That gives me a 26. A 26 plus 6 gives me a 32, and a 32 plus a negative 2 gives me a 30. Okay? The more work you show me, the more opportunity you're going to have for partial credit. If you just plug the whole thing in your calculator and hit equals, you might get a mistake, and then with no work to back it up, I can't give any partial credit. Okay? We talked about kind of mentally making that switch. In my mind, I would not switch anything here. In my mind, that's a negative 9, a negative 21, and a negative 3, even though it's not written that way. And I'm going to add them all together, even though those are subtractions, because if I do the physical changes, now they all become add the opposite. And now they are all additions, and they are all negative numbers, except for the 5, okay? I like to kind of mentally do that, but I've got years of practice at this also, so, you'll get to that point. All right, a 5 plus a negative 9 is a negative 4. Okay, now everything else is negative, so this should be easy. A negative 4 plus a negative 21 is a negative 25. And a negative 25 plus a negative 3 is a negative 28. Right? We're multiplying. When we multiply in number 30, if I have an odd number of negative signs being multiplied, the answer is going to be negative. If it's even, the answer is going to be positive. So the easy part is take 2 times 5 times 4. We're going to get a 40. And then we just got to figure out if it's positive or negative. And because there's an odd number of negatives at work here, it's going to be negative. Okay, Here's a couple more involved order of operations here. Number 31, parentheses exponents, please excuse. Remember, this plus sign's kind of like the great separator, so I really can do the parenthesis operation and the exponent operation simultaneously because this plus sign is separating those two pieces. Okay, so in the parentheses here, I've got negative 10 divided by positive 5, that's negative 2. And if I take negative 3 in parentheses and square it, it gives me a positive 9. Okay? So now I'm down to multiplication here. Negative 2 times negative 2 is positive 4. And just like that, I'm down to additions and subtractions. And I'm going to get a 12 out of that deal. Okay? How about this one? Again, I've got parentheses, exponents, the great separators of these subtraction signs. Okay, so I can knock out this exponent process. Negative 5, no parentheses squared, remains negative, and it's 25. Bring down the minus. Here's negative 4 in parentheses squared becomes a positive 16. Bring down the minus, and in this parentheses, let's just do one thing at a time. We'll leave the 12 and the minus alone. No parentheses here. 3 squared is 9, so it's 12 minus 9. Okay, let's do one more thing here and clear out that parentheses. 12 minus 9 is going to be a 3. Okay, let's mentally do this one. All three of these are negative numbers, even though that's written as negative 25 minus a positive 16 and minus a positive 3. I look at all three of those as being negative, and I'm simply going to add them together. Okay, so a 25 and a 16 gives me a 41, so it'll be negative 41 minus 3, negative 44. Okay, this was scraps from before. Okay, multiplying powers of 10, pretty easy. When we multiply powers of 10, we add the exponents. So that's going to be 10 to the 2 plus 8, 10 to the 10th power. Add the exponents. The base remains the same. Negative 5 or negative 6 plus negative 5 is negative 11. Okay, when I divide, I'm going to subtract the exponents. So it's still going to be a 10. I'm going to have 16 minus 12, 10 to the power 4. Trying to gauge if I should probably make 3 videos out of this deal. Decisions. Well, we'll do one more page. Alright, number 36. Once again, I'm subtracting. Let me write this one out. So it's going to be negative 9 minus negative 1. So that's negative 9 plus 1. That's 10 to the negative 8th power. Okay? This one I specifically say write with a positive exponent. Generally speaking, when we have a negative exponent, we want to clear that negative exponent out of there, okay, except when it's in scientific notation. Here I wanted you to just understand and how to do the division. I wasn't so much worried about what we did with this answer. This is a fine answer here, but down here I don't like that negative exponent. I want us to do something about it. Well, what do we do about it? We just move it to the other part of the fraction, and then it becomes a positive exponent. So 10 to the negative 18th is the same thing as saying 1 over 10 to the positive 18th. Okay? Standard notation means let's get rid of that scientific notation. Just give me a plain old number. So I'm going to multiply by 10 to the 8th power, which means I'm going to move this decimal 8 places to the right. Okay, 3 places there. I got to go 5 more places. So 7, 7, 7, 1. 1, 2, 3, 4, 5 zeros. Go back and fill in our commas here. Let me be consistent with my 7. Sometimes I put the little dash and sometimes I don't. 777,100,000. Okay. Negative exponent means I'm moving that decimal to the left 4 places. So 1 place gets me there. I need 3 leading zeros. Not counting that. So 0.0000378. Okay, to go into scientific notation, when we have the standard notation, now it's kind of the reverse procedure. The decimal's here, but I want to put it there. So I want 5.34 times 10 to some exponent. Well, how many decimal shifts did we have there? 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8th. Likewise here, I want the decimal to be right there. So I want 3.91 times 10 to the 1, 2, 3, 4, 1, 2, 3, 4, 5 times, so 10 to the negative 5th. Okay, I'll end this video here and we'll wrap it up with the next one.